Here we have a question on increasing and decreasing functions. This is taken from an Edexcel textbook, and we're asked to show that the function f of x equals 4 minus x times by 2x squared plus 3 is always decreasing. So it's important to note that decreasing functions have a negative gradient. So for instance, look at this part of the curve, of any curve. It's downward sloping on this section. And at every point on that section, I have that the gradient is less than 0. So for our function given there, f of x equals 4 minus x times 2x squared plus 3, we have to show that the gradient of f of x is always negative in order to show that it's always decreasing. So let's write f of x equals 4 minus 2x cubed minus 3x by expanding the brackets, being careful with the minus sign. So now I have three polynomial terms. I can find df by dx. If I differentiate 4, it disappears. If I differentiate 2x cubed, I multiply down by the 3 and I subtract 1 from the power. If I treat this term here as 3x to the 1, it's 1 times 3x to the 0. So we differentiate polynomial terms by multiplying down by the power and subtracting 1 from the power. And then it's very simple just to tidy this up to get 6x squared, minus 6x squared minus 3, where x to the power of 0 is 1, so we're just doing 1 times 3 times 1. Okay, so this is always negative. And that is because x squared is always more than 0. So actually more than or equal to 0. If I put any number into x squared, any x, then it comes out positive. If I then multiply it by minus 6, that term's negative. And then if I take away 3, it's even more negative. So minus 6x squared minus 3 is always negative. So df by dx is less than 0. So f is always decreasing. And it's always strictly less than 0 because of that minus 3. We could have x equals 0. That's when that will be at its minimum. So 0 minus 3 is minus 3, so it's strictly always negative. And that concludes the question. So check out studyworld.com if you want to find out more about increasing and decreasing functions or how to sketch derivatives.